So I have now the pleasure to introduce the second lecturer of today, Dr. Caterini Delegou. She is a member of the scientific and teaching staff of the School of Chemical Engineering, the Material Science and Engineering sector at the National Technical University of Athens. She will speak about characterization, archaeometry, archaeogene of the building materials of the Holy Aedicule, and she will deal with the compatibility of conservation interventions we performed there. Caterina, you're having the floor.
Thank you so much. Good afternoon, everybody. So there are two distinct parts for this lecture. The first one is in relation with the characterization of building materials, archaeometry and archaeogene. And we're using the emblematic example of the Holy Aedicule and its rehabilitation project. And in this first part, we're going to try and answer the following questions. How can we interrelate archaeometry with building material science? How can we validate historical sources and testimonies by archaeometry and building material data, and vice versa? If the nexus, archaeometry, building materials, historical sources can provide solid and rigorous scenarios about the past, and is this nexus the step from interdisciplinarity to transdisciplinarity? Can we start building a solid methodological approach towards this direction? So the first thing is to present the archaeometric dating results that were accomplished in collaboration with our research team from the National Technical University with the University of Peloponnese and Professor Nikos Zacharias. Then the techniques of thermoluminescence, and in particular the optically stimulated luminance, the OSL, was used in order to have the dating periods of the samples taken. Those samples was were mortars in the masonries of the Holy Aedicule. And in order to have these results really shortly, I have to say some basics on the theory that we are actually calculating the radiation dose that it is the radiation dose of the cosmic rays that are absorbed, that is absorbed by the compounds of quartz and feldspar, as well as the radiation dose of cosmic rays that is absorbed by uranium element, thorium, and potassium. So, except from the OSL technique, XRD was for the mineralogical composition of the mortars were also applied, and XRF for the chemical composition of the historical mortars. So, the next. The location of the collected mortar samples, you can see that they are all located in the Holy Tomb area. The first one, the MDO, is located within the Holy Tomb. Two of them are located within the masonry, because if we look of the monument, as Dr. Moropoulou already explained, from outside to inside, we have a multi-leaf masonry. The stone facings here is the gray color, the filling mortar, which is the yellow color, the masonry, a rubble masonry, and of course the remnants of the holy rock here on the north and in the west. Actually, in the west, Dr. Moropoulou and the GPR investigation saw that there was a major crack here in the holy rock. So, the first mortar sample, ArcMDO, was collected inside the holy tomb. As you can see here, the amber-hued marble plate, plate that we are still worshipping today. This plate was shifted out of position, and out of surprise, we realized that there was a second marble plate, a gray marble plate, underneath the top amber-hued plate, which was a fragment, and its existence was only a hypothesis due to some testimonies like the Bonifacio di Ragusa letter, or a description of Maximus Simeos, who was a collaborator of Calfa Komnenos architect. So underneath this gray marble plate, you could see that we found enough material of this bedding mortar, the archaeometry, that was collected and dated by OSL. And underneath this mortar was the Holy Burial Bed rock was found. So, if you see the section, a schematic representation, you can see the exact place of the sample. Its mineralogical composition by the XRD pattern was gypsum, calcite, quartz, and anhydrite calcite. These OSL results showed us that the calendar standard age was in the middle of the 4th century, at 345 AD, that is the Constantinian era. So we're sure that Tomb of Christ and the initial burial bedrock surface here were actually covered by marble slab early on from the Constantinian era, at least from the top, because from the side there are many testimonies that there is a vertical plate, marble plate, where 3 holes existed, so the pilgrims could actually put their hands inside the holes and touch the holy burial bedrock. Following that, the other 2 samples that we had investigated was RC Empede, M5, I'm sorry, that is a mortar found at the end of this big crack of the holy rock. These 2 marble facings, marble plates of the interior facing of the holy tomb chamber were removed in order to install a window that you can see here in order to provide visibility of the holy rock. So we took 2 samples, one from the lower part of the holy rock crack, and the other one was collected behind the marble facing above the window. That is here, behind the marble plate that is still in place, and it was in contact with the holy rock from behind, and from its front face, it was behind this marble facing. So mineralogical composition of both samples showed, as you can see from the XRD patterns, that we are talking about gypsum-based mortars, along with calcite, and in RCM5 here sample, there was also determined a quantity of quartz. And the calendar standard age of the RCMN was again during the Constantinian era, and in 335 AD. And that caught us by surprise. It wasn't a result that we actually we were thinking about. On the other hand, the other sample at the lower part of the holy rock crack It was dated back to the 16th century during Renaissance at 1570, and it is placed during the Reconstruction era, in the Reconstruction period of Boniface di Ragusa in the Renaissance. So how can we have two mortars located so close to each other, but as far as it concerns dating, they are centuries apart? So the mortar sample from which is in contact with both the holy rock and the marble facing, shows us give us the indication that this specific marble panel could have been placed since the Constantinian Edicula, since the Constantinian era. If the other possible scenario that could have taken place is that this marble panel could be a later addition, and then we can only assume that the holy rock was at least plastered in the interior and not bare during the Constantinian era. Regarding the second mortar at the lower part of the holy rock crack, it is the things are simpler. It is definitely a restoration mortar placed there during the reconstruction of Boniface di Ragusa, and there is a chance that these marble panels that they are now removed in order to have the window and make the holy rock visible. These panels could have been placed or replaced or even reattached during the Boniface restoration, because replacement and reattachment of marble panels, especially in this period, was a common practice, and there are many testimonies verifying that this reattachment and replacements of marble slabs were made throughout centuries in the Holy Aedicule. The next sample was located and collected from the low entrance of the Holy Tomb chamber. From the Chapel of Angel is here, and here is the Holy Tomb, and this is the low entrance. So the marble slab was removed temporarily during the rehabilitation interventions, and here you can see where we collect the TEN M1 sample. This sample mineralogical composition is also gypsum based. It is dated back to the middle of the 11th century, and its calendar standard age is 1040. So it can be dated to the Byzantine reconstruction of the Edicula, just after the destruction of Al-Hakim, and it could be attributed to Constantine Monomachos or Michael, the Paphlagonian Byzantine emperors. And however, due to the uncertainties of the OSL measurement, there is a possibility that this area could have been reconstructed during the Crusaders period at 1019 AD. The next sample is located here at the north west corner of the Holy Tomb. You can see that it is located inside the masonry. It was collected from the masonry section in this point over here. You can see the amber-hued marble plate, the edge of the amber-hued marble plate, the one that we are still worshipping today. The gray marble plate, the fragment one that the archaeometry sample, that it is dated in the Constantinian era, was found. This is the burial bed rock, and the mortar was collected from this corner over there. It is also Egyptian-based mortar, and its calendar-centered age is at 1560. That is the period of the reconstruction by Boniface di Ragusa. For once more, as you can see, this sample has some specialty, because it carried black crusted red tesserae. These tesserae are red, but they are covered by black crusts. This mortar sample, this part, was embedded within the masonry, and the black crusted red tesserae were embedded in the mortar in a rather disordered manner. They were not well positioned within the bedding mortar of the possible mosaic that this sample could be taken from. So there are two possibilities, two scenarios regarding this sample. The first one is that this is the part of the setting bed of a mosaic that was created during the Boniface di Ragusa restoration era, or it could be a conservation of an older mosaic during this era. We think that it is most possible that the later concept is more valid because of the disordered positioning of the tesserae in the mortar, and especially because there are some historical testimonies dated back to 1047 and 1149 AD that describe the presence of mosaics in the Holy Aedicule, and in particular just under the Holy Tomb, the position where today there is the curved depiction of the Jesus Christ, the resurrected Jesus Christ. In any case, it seems to us that it was placed in the masonry during subsequent restorations in a way to protect something precious and to protect something that is of high religious value, having a religious value, which a fact that it was also a common practice during this period and throughout all the centuries of Holy Aedicule's life. The next mortar sample was collected from again within the masonry, the rubble masonry here. It is located under the panel area N3. As panels, we were when we're talking about panels, we are talking about these arched areas where the stone facings were dismantled and they were removed in order to be conserved and restored, and in the same time giving us the possibility and the potential to watch and see the preservation state of the masonry underneath and behind the masonry behind the stone facings. So as you can see, this this sample was taken from this area here, that is the northwest corner of the Holy Tomb. You can see here the remnants of the Holy Rock over there. It was it was in contact with the Holy Rock, and This sample has a different mineralogical composition. It is a calcite-based mortar presenting quartz, thomsite, andrigite, and gypsum. It is dated back to 1815 AD. That is the period when the reconstruction of the monument took place by Kalfas Komnenos, the Mytilenean architect. Since this sample was collected from a section of the inner masonry of the structure, confirms the fact that Komnenos, during his restoration in 1809 to 1810, restored the inner masonry behind the exterior stone slabs that we know that he actually placed there. So we believe, as far as it concerns the this particular mortar sample, that it is possible that Komnenos actually placed it in this corner, really close to the holy tomb and holy burial bedrock, because of its high religious importance. Actually, Maximus Simeos, at his testimony, describes that Komnenos opened the masonry and watched the holy tomb from this particular corner here. So everything seems to actually fits in together. So conclusively, we're having 4 different chronological periods, so that they are in correspondence to construction phases that we already know: Constantinian era, Byzantine era, Renaissance era, and Komnenos, Kalfas Komnenos period in the 19th century. All the mortars investigated, except for the Komnenos mortar, are gypsum-based mortars, a fact that indicates continuity in the production technology of the materials, of the building materials. The high amount of gypsum detected in these mortars show us that, except from the binder, that it is gypsum or gypsum lime, a substantial part of the aggregates are also of gypsum, or is also made of gypsum. And another conclusion is that regardless of the role of the mortar in the structure and the area of application, the choice of materials seems to be more or less the same. We have to point out, of course, regarding the Komnenos mortar and its diverse the composition, that is a lime-based mortar, and the presence of andrigite and thomsite are not decay products in these lime-based mortars. You will see in the next lecture which is focused on mortars, exactly why. And it's an indication that he used aggregates deriving from the Hatturim formation in the Judean desert. So local products were seems that had been used during the reconstruction phases of the Edicula. Another now archaeometric analysis and investigation that took place concerns the white marbles of the Holy Tomb. Our goal here was to validate and to see if all the historical testimonies that the indoor white marble slabs of the monument, as well as the gladings of the Holy Tomb, were of precocious marble. So, to cut the long story short, because we need to pass to the next, I don't know how much time I have. we have to pass to the next, to the second part. And we performed petrographic and isotopic analysis. This work was in collaboration with IGME, the Institute of Geology and Mineralogical Exploitation of Greece, as well as with National and Kapodistrian University of Athens. You can see here the images from the optical microscopy, and where we can see the characteristic heteroblastic fabric, and that we have a texture of a mortar type. And here we can see the maximum grain size values of all the investigated samples, and here are the isotopic the isotopic signatures of the samples as far as it regards oxygen 18 and carbon 13. And here is the isotopic discrimination plot among the Holy Aedicule samples, and all the relevant fields of ancient marble quarries, that is Carrara, Phasos, Paros, Pedeli, Naxos, that they were usually used in ancient and medieval ages for monuments construction. As you can see, all of the Holy Aedicule samples are located inside the area of Proconsus marble, of Proconsus quarry. And another one, isotopic discrimination plot, give us the information that all the investigated marble samples from the Holy Aedicule were actually originated from the island of Proconsus, and in particular they belonged to the variety type of Proconsus 1. None of them were from Proconsus 2. The next step of this this work was to make an intrasite discrimination of Proconsus quarrying locations. We tried to figure out if we could locate the particular quarries in Proconsus Island. Let me say that Proconsus Island is the Marmara Island in modern Turkey. And so we managed to narrow down all the, from tens of different quarries in Proconsus Island in few. Actually, there is a particular sample, the 13th one, that it could be quarried only from one single quarry site in Proconsus, the C5B. This is important because this particular sample is from the marble plate that we saw earlier, that was removed for the visibility window to the holy rock. This is where it came from, this particular plate that it is now removed, that it is not in place. So this actual work that we've done with the archaeometric analysis of the marble plates could be actually continuous if we can compare samples of this particular quarries in Proconsus Island, and if we could have access to testimonies and to historical archives of the Proconsus Island quarries, in order to possibly find out when the transportation and the trade of these marble plates actually occurred for the glading of the Holy Aedicule indoor masonries. I'm skipping all this, and the major the major outcome of this work was that Proconisian marble, and in particular the Proconsus 1 variety, was a material of choice for the glading of the Holy Tomb, as well for the interior facings of the Holy Aedicule, because all of the examined samples were derived from this particular variety. Another part for the questions that were posed by me earlier is the archaeogene of building materials of the Holy Aedicule. We're attempting a new approach, so this is rather a teaser of what it is going to happen in 10 days from today during the TMMCH conference and that we are holding. And then there we're going to make an announcement entitled Metagenomics of the Built Cultural Heritage, Microbiota, Characterization of the Building Materials of the Holy Aedicule of the Holy Sepulchre in Jerusalem. So in this paper, we are trying to merge the advanced technologies of metagenomics and bioinformatics and correlate them with building material science, archaeometry results, and historical evidence. This is also a work in collaboration of our Laboratory of Material Science and Engineering and in NTUA with DNA Sequence, SRL, the Aristotle University of Thessaloniki and the School of Informatics, the Center for Research and Technology, Hellas in Thessaloniki, and the Institute of Applied Bioscience in Thessaloniki. So please stay tuned, and we will speak of this issue in 10 days from today. The second part of this lecture is about compatibility of conservation interventions and how we can ensure compatibility assessment in an active construction site. Commonly and usually, all of us, the researchers, make diagnostic studies before the actual construction, and we assess and we evaluate the rehabilitation interventions, conservation interventions, restorations interventions after the end of the construction of the project, not during. I have to say from my personal experience during the rehabilitation project of the Holy Aedicule that it is the very valuable information can be extracted when monitoring, compatibility monitoring and interventions monitoring take place during the actual construction interventions. The other issue is how can compatibility assessment process affect the sustainability of a monument in a transdisciplinary way? How can non-destructive monitoring of conservation restoration work support decision-making? How can non-destructive monitoring cause reschedule, readjust, and modify the interventions applied? All this happened in the case of the Holy Aedicule. So let's take a brief look at this because I only have 20 minutes. Okay, non-destructive techniques are used because destructive sampling is prohibited or it is rather limited, and they have certain unique capabilities. I won't say more, I'll skip that. We used a vast array of non-destructive techniques and, of course, analytical ones because sampling took place during the rehabilitation project. In the following slides, the entities The non-destructive techniques that we're going to see is digital microscopy, that is a portable microscope that no treatment of the material is required. Infrared thermography, where actually measures is a technique that measures the thermal variations of the material under investigation and produces an image where different temperatures are depicted by different colors, false pseudo colors, and so we have a temperature, or you can say a thermal map of the area that we are investigating and the materials that we are investigating. And the other techniques is colorimetry, a portable spectrophotometer for measuring color variables. In conservation science, we usually use the CLab color space. So all the results presented here will be in accordance with this color space. So the first problem is the one that you can see on this slide. Due to the existence of the metallic frame that the British mandate actually constructed in order to stop the deformation of the Holy Aedicule, it suited very much for the pilgrims to positioning their burning candles there. And so the candles were burning close or even in contact with the architectural surfaces of the Holy Aedicule. Even moreover, some candles, as you can see here, and this is a bounce of 33 candles, because 33 were the years of Jesus Christ when he was crucified and then resurrected. 33 burning candles are were extinguishing all the time by hundreds of pilgrims every day on the stone facings of this of the monument. As you can see here in the thermograph, enormous temperatures were actually applied on the stone facings, up to 120 degrees. So all this situation resulted in high temperature variations of the stone facings, significant thermal stresses developed on the stone facings, aesthetical and physicochemical degradation, and accumulation of black and oily depositions. As you can see here, the situation was rather harsh. So we removed, during our diagnostic study, we removed the burning candles. And just after removing the burning candles, we received those two thermographs where we could see that the thermohydric behavior of each building material was differently affected per height and as well in depth, resulting in a corresponding thermohydric anisotropy. This was not good, not only for the stone facings, but for the masonry underneath, behind the facings. 3 hours later now, because we managed to measure and we managed to the pilgrims not to position any burning candles that particular day. 3 hours later, after removing the burning candles, as you can see in the thermographs here, the cooling down of the facade takes place with a different rate per height and per panel, showing that there is an anisotropy of the heat transport among the different building materials. So all of this thermal stresses cycle, to a large degree induced by the pilgrims on a daily basis during the visiting hours of the Holy Aedicule, deteriorated the preservation state of the building materials and accelerated their decay. So, what to do? Part of what we've done during the rehabilitation project You see how the facades were before cleaning. We applied pilot cleaning interventions. We used assessment techniques like digital microscopy, scanning electron microscopy, colorimetry, and thermography. And we had this good, I believe, and compatible, first of all, final result. Of course, all the stone slabs underneath this arched area, or the stone slabs of the panels, were transferred to the conservation lab, which was located in the Franciscan Gallery. And the conservation lab was the heart of the conservation interventions, where all of these techniques applied for the dismantled slabs. And furthermore, pilot applications, assessment using NDT and analytical techniques, and the final application on the monument facade was made with the under the same way. And so in the inauguration day of the last day of the Holy Aedicule rehabilitation project, we have this clean and protected and well-preserved architectural surfaces. 2 years after that, a date that I managed to visit Jerusalem for the last time, you can see that the good work is still evident. And what we need to say is all the above results motivated the Christian communities to discontinue the pilgrims' practice of burning and extinguishing their candles onto the monument's facade. So that's the reason why 2 years later, from the last date of the project, we can still have protected and well-preserved stone surfaces in the monument. Continuing the posing questions, and in order to, I have some time left, and not to delay so much. Another application of the IRT, of the infrared thermography, was to investigate the masonry just after the dismantling of the stone slabs in the panel areas. This is the panel area. This is the panel N2. That means that it is the second panel from the north, at the north facade, the second panel measuring from the entrance of the Holy Aedicule, that is from the east. So we can see that there is intense rising damp from the underground, lower temperatures at the lower part, zone 2, where at the upper part of the panel of the masonry, we can see higher temperatures. This unhomogeneous temperature distribution indicates for once more anisotropy regarding moisture transfer phenomena, and can explain the disintegrated state of the filling mortar layer, affirming our diagnostic study. If you can remember the sections from the first part of the archaeometry results of the mortars, we were having the stone facings, the filling mortar, the masonry, then for once more, and then the masonry, and then the interior marble slabs. So this is the filling mortar was totally disintegrated. When this filling mortar was actually removed, the rising damp from the underground was still evident. And so we realized that there is an intense problem, and that's why we decided to investigate the underground areas of the Holy Aedicule and the Holy Sepulchre as a whole. Part of such results Dr. Moropoulou demonstrated in the previous lecture. And so a single measurement or some few measurements in during the project indicate us a problem, a wider problem than the one that we could imagine by other experimental results. Another issue that it was rather impressive, well, at least in my mind and most of the team's minds, we always believe that historical materials are always compatible. They are always compatible among to each other. Well, in the Holy Aedicule, at least, this is not the case. We found out that there is incompatibility between the different joint mortars, as well as there is incompatibility between joint mortars and building stones. Of course, this is possibly due to the fact that we have many construction phases during the last, let's say, almost the last centuries. So probably this was inevitable. And another part was that there were detected areas at the defected areas at the upper part of some panels, like panel N4, north facade, the fourth panel from the entrance of the Holy Aedicule, which was still evident even after the pointing of the restoration mortar was accomplished, was performed, had finished. So that made us that saw us the necessity for grouting the upper zone of the monument, because in the first phase of the at the beginning of the project, we performed a grouting, grouts, but till the two-thirds of the masonry and height, and we thought that this was okay, that was perfect. However, ongoing research during the project showed us that this wasn't enough. So in the last part, we're going to discuss about the wall painting of the mirror bearers. They are located in the Holy Tomb chamber, here just above the Holy Tomb. In this wall painting, the mirror bearers, the angel Michael and Gabriel, and the Virgin Mary are depicted. And you can see here, after the conservation interventions, how they looked like. Unfortunately, it is not a pilgrim today. It's not able to watch this really marvelous wall painting because of the 64 candles that they are hanging on the top of his head here, and so it's impossible for a pilgrimage to see the wall painting. Anyway, now you can see here all the mirror bearers and how they are located northwest, east, and south of the dome. You're seeing the metallic structures where the 64 candles are hanging, were hanged before the project and now after the project. Anyway, as you can see, the preservation state of the mirror bearers of the wall painting wasn't good. This is, we're going to talk about the part of the wall painting of the Virgin Mary. Cracks of several and different widths can be found. this is the crack that Dr. Moropoulou was talking all about. This is the middle crack shown here in the thermograph, which is the crack of the larger width. We had another one here, and another one just before the depiction, the part of the wall painting that depicts is balusters. It is like they are standing, all the mirror bearers and the Virgin Mary in a balcony. Okay, and they were in a bad preservation state, and black soot particles were accumulated because of the hanging oil lamps, and the gilding was not evident. Actually, at the beginning, we realized that there were gilded parts of the wall paintings due to the different emissivity, due to infrared thermography measurements, due to the different way that the gilded parts emitted in the thermograph. Anyway, so during the preservation, during the conservation interventions, just after cleaning the wall painting and accomplishing the cracks sealing, and during then consolidation, because the bedding mortar of the wall painting was detached. Here, if you can see, detached from the stone masonry that it was behind the wall painting. So consolidation treatments were required. The materials used for the crack sealing and for the consolidation were commercial lime metakaolin based materials. You can see here that now the gilding is rather evident. Microscopy images about all the sealing of the cracks, and we can detect here in this zone that the detached areas that have been consolidated can be now detected through IRT, through infrared thermography, by lower temperatures, demonstrating the exact sections that the consolidant was spread, and also indicated that both areas had been adequately consolidated. Finally, after the protection and the aesthetical conservation, we can see that the whole area of the Virgin Mary painting presents a much better temperature homogeneity as far as it concerns the temperature distribution. And this fact indicates the compatibility of the applied conservation and restoration materials and interventions. So in this second part, we saw that the entity investigation in an active construction site during conservation works, even though many difficulties were there, we didn't say anything about it. I just will say that the presence of scaffoldings, that they are affecting the measurements, metal frames, buttresses, personnel, heavy machinery, time restrictions, pilgrims, etc. Entity investigation proved decisive because not only for the compatibility evaluation among historical building materials and restoration materials, but also because they led to begin and complete the survey of the underground area of the Holy Aedicule. It so demonstrated the necessity of the upper zone of the monument for the grouting, and also motivated the three Christian communities to discontinue and to make the pilgrims stop practicing burning and extinguishing their candles onto the Holy Aedicule facades. Thank you. This is what I had to say to you, to share with you today.
Thank you, Dr. Delegou. It was a very nice presentation. We traveled with you through history, via archaeometry, and through the materials and conservation interventions at the Holy Aedicule. It was very vivid, but at the same time, you were assessing materials and conservation interventions, and this is a tool for our scholars, colleagues, and students for further emblematic monuments restorations.